Hello and welcome back. Today we'll be looking at combinatorial proofs. The combinatorial proofs is different from algebraic proofs where you expand all these things in terms of factorials, you write all the formula and then cancel items and show the left hand side and right hand side are equal. But it might be nice to do it that way, but it doesn't tell you the combinatorial meaning behind it. Combinatorial proofs, on the other hand, help you understand combinatorics in a different way. The way I'm going to prove this would be is to show that these two things, the left hand side and the right hand side, represent, and they are the answers of the same question. That's why they must be equal. So firstly, I want you to think of different questions which gives left hand side as the answer. I'm going to tell you two such questions, and I want you to figure out more such questions. The first question would be, okay, so we have n different people, and we want to choose R members. That would be n choose R, but we want R times n choose R, so we want R members and assign a leader. So for every such collection of such R member committee, we can have the first member as a leader, the second member as a leader, and that's why we have R different possibilities for every single of this. And the total number of ways we can do this would be R times n choose R. That's the first question. Another question I can think about which gives the same answer would be, okay, take a set X that has n members. The number of subsets of X would be 2 to the power of n. We don't want that. The number of subsets of X which has only R members or R elements would be n choose R. Well, but we want R times n choose R. So what I can ask is, okay, let's find the sum of numbers of elements in all the R element subsets of X. So sum of number of elements in all the R element subsets of X. There are n choose R member subsets of X, and each of them have R members. So sum of all the R elements of sum of the numbers of all the elements in R member subsets would be this times R, which is what we want. So these are two questions, and I'm going to use the first question to prove this. So this means, and we are choosing R member committee and assign a leader from n different people. So that's one way of thinking about this. What's another way of thinking about this? Okay, let's put n different people in a line. Doesn't matter in a line, they could be inside the classroom, but I think it would be easier to say. Let's write them as 1, 2, and all the way to n. Okay, so another way of thinking about this would be, okay, we want to count all the R member committees in which the person 1 is a leader. Well, how many such committees are there? Well, we want 1 to be inside the committee because he's the leader. So we only need to choose R minus 1 more people, remaining people, and because 1 is already inside, from n minus 1 different people. That's the number of committees in which 1 is a leader. The number of committees in which 2 is a leader would also be n minus 1 choose R minus 1, because 2 is already inside, and we want to choose the remaining people as the member because 2 is the leader. And same thing can be done with all the members. That would give us n copies of this thing. So that would be n times n minus 1 choose R minus 1, and there's a combinatorial proof. So as an assignment, I know you guys don't like to do assignment. As an assignment, I want you to do the second. I want you to use the second question to prove this. Thanks for watching. Please like, comment, and subscribe.